In this video, I'm going to do an introduction to hypothesis test, and then in the following videos, I'll go through each of the sections and some of the problems you might encounter and how to solve them. So with a hypothesis test, the idea is there's a population parameter, maybe a mean, maybe a proportion, and we want to challenge or test whether that's actually true or not. And so we're going to use what we know from statistics, we're going to use the central limit theorem, and we're going to test whether a given hypothesis is true or not. So you always start by stating your claim, stating your hypothesis. There's always a null and an alternative. So we'll have two hypotheses every time. The null hypothesis always has a statement of equality. It could be something like the population mean equals 20, or the population proportion is equal to 35%. The alternative hypothesis doesn't have an equal sign. It's going to either be a less than, which is a left tail test, a greater than, which is a right tail test, or simply not equal to the value, which is a two-tail test. So for example, if your null hypothesis was the population mean equals 20, your alternative could be the population mean is less than 20, or it could be that it's greater than 20 or not equal to 20. Now, if your null hypothesis was the population proportion is 35%, again, your options for the alternative are less than 35, 0.35, greater than 0.35, or not equal to 0.35. And so now I'm going to go through a couple of examples just to illustrate the whole process here and how it works. In my examples, we'll be testing population means. And the whole idea of hypothesis testing is going to rely heavily on the central limit theorem. So recall what that says. It says if we have a population and we look at the sampling distribution for a certain size sample from that population, if their samples are at least size 30, we know the sampling distribution is normal. And recall that from the book. That was back in chapter 5. So if we have samples of at least size 30, the sampling distribution is going to be normal. And we know the mean of that sampling distribution is going to be equal to the population mean. And we have a formula for how to get a standard deviation for our sampling distribution. So here's the idea. There's a population mean that we want to test. Let's say the mean equals 20. It could be anything. I'll just go ahead for this example. We'll say the population mean equals 20. That could be our null hypothesis that the population mean is 20. For our alternative, it could be any one of these, but I'll go ahead and just show what greater than looks like here. So our alternative hypothesis could be the population mean is greater than 20. So what we know from the central limit theorem is if this is true, and we're going to assume it's true going in, when we gather a sample, our samples are going to follow the normal distribution, which means most of our samples are going to have means close to 20. We go out and gather a bunch of samples. Most of them are going to come in with a mean somewhere close to 20, because that is, if this is true, if our population mean is 20, that's what we know from the central limit theorem. So how a hypothesis test works is we go out and gather a sample. If the sample comes back close to 20, then we say there's not enough evidence to reject the null hypothesis. That's what we expect. The sample is close to 20. That's what you'd expect. So we just go with the null hypothesis in that case, and we would say the null hypothesis, we're not going to reject it. We're going to go with that. Now, if you get a sample that's way out here in the tail, way far, and so in this example, way far in the right-hand tail, because we're doing a greater than, we're checking for values greater than 20. If we get a sample out here, and we'll have a cutoff, it'll differ from problem to problem, but a common one is 5%. So if you go past the mark, where only 5% of your samples would have a mean past that mark, that's really unusual and really rare. So there's two options here. Either you just got a really unusual sample, and the mean really is 20. That's a possibility. But the more likely possibility is that the mean's actually some value greater than 20, and look where this would fall if the mean was actually some value greater than 20. Then the normal from the central limit theorem, the distribution would be centered around this value greater than 20. So we would expect samples to be centered around this value greater than 20. So this sample that's really unusual and really unlikely because it's far away from 20 is actually what you'd expect if this is true. And so when we get this situation and we get that unusual sample way far out in the tail, what we do then is we reject the null hypothesis and we assume that the alternative is true. So that's hypothesis testing in a nutshell. If you had a less than that you were testing, if your alternative hypothesis was that the mean is less than some value, you would be looking for samples way far out in the left-hand tail. Usually 5% is our cutoff. So a sample that's only happens 5% or less of the time, a p-value of 0.05 or less. If that occurs, you're going to assume that rather than you just got unlucky and got a really unusual sample, which would be the case if the mean really was 20, you're going to assume the mean's not 20. You're going to reject the null, assume the alternative is true, and that you got a sample that's pretty typical, pretty normal, given that the mean is some value less than 20. So we'll be accepting the alternative hypothesis that the mean's less than 20. And for a not equal to, you're actually testing both tails. So if you wanted 5% in both tails, this cutoff would actually be 0.25 in each tail. And in that case, if we get a sample way far out there, we again are going to reject the null because it's very unlikely to get a sample way out in the tails, and just assume that the alternative is true. We don't know if the mean is, or we don't know what the new mean is. We're just accepting the alternative that the mean is not equal to 20 if we get something way far out in the tails. So to wrap up, that's hypothesis testing in a nutshell. Notice I never said that we prove the null hypothesis is true. We can never use this method to prove it's true. If we get a sample back somewhere close to the null hypothesis, somewhere within, it's not way far out in the tails, there's not enough evidence to reject null. There's no reason to believe it's wrong, but we have not proven it's true. If we get a sample that is way far out in the tails, what we say then is we reject the null in favor of the alternative. There's reason to believe the alternative is true instead of the null. So that's when we get the evidence. That's when we really get stronger evidence, is when we reject the null in favor of the alternative. So a lot of times, if we're trying to prove something, we try to make the alternative hypothesis what we're trying to prove. And then if our hypothesis shows that we can reject the null and accept the alternative, then we have a stronger statement. Because if we make the null hypothesis what we're trying to prove, and it comes back that we don't reject the null, we really haven't said anything strong. We just said we can't reject the null. Not that we've proven it's true or any sort of confidence in its value. I'm going to wrap up the video looking at this table that helps you translate words into setting up your hypothesis test correctly. So your null hypothesis always has to have the statement of equality in it. So like greater than or equal to, the equality statement would be a null with the greater than or equal to, which your alternative then is everything else. So that would be less than whatever your value is for k. If it's 20, then you would have the nulls greater than or equal to 20, the alternatives less than 20. Some other things that mean the same thing: at least k means greater than or equal to, not less than some value k means greater than or equal to, so you would still get the same null from all of those. And less than, below, or fewer than all mean less than. Similarly, you have some similar words here that mean the opposite. And then your last situation where you have equality, just pure equality, equal to, exactly, or just a statement that says the mean is some number like 20. That's how you get the null with an equal sign. Or if you get something that's clearly just stating not equal to, that again shows that you're going to set up the hypothesis test like this. Of course, if you're looking for the mean not being equal to k, then not equal to always has to be your alternative, because in your null hypothesis, there always has to be a statement of equality, whether it's just equal or less than or equal to or greater than equal. So watch the future videos. I'll be going through each section and then some of the problems you'll see on your assignments.